Good morning. Myself, Murali Krishna, Assistant Professor, Murali Institute of Technology, Department of Physics. Today, I am going to discuss about the fiber optics. In this session, I am going to discuss principle of optical fiber, numerical aperture, acceptance angle, types of optical fiber, attenuation or losses of the optical fiber, application of optical fiber. And this is the structure of the optical fiber. The optical fiber is a cylindrical waveguide which the optical fiber is a cylindrical, thin, transparent, and flexible dielectric medium which transmits the light by total internal reflection. This is the structure of the optical fiber. The inner core is the inner medium is the core material. The core is surrounded by cladding. The cladding is surrounded by buffer jacket. The inner core, the refractive index is N1 and the cladding refractive index is N2. Here, the refractive index of core is more. Refractive index is cladding is less. That is N1 greater than N2. This is to get the total internal reflection, it must satisfy the two conditions. One is the N1 greater than N2. Second one is the angle of incident must greater than the critical angle. Here, these are the first condition N1 greater than N2. That means the refractive index of core is more than the refractive index of cladding. And second condition is the angle of incident. Here, this is the angle of incident. Here, this is the core material. This is the cladding material. You can draw one normal here. Now, this is the angle of incident. Suppose a light launched into the optical fiber and it strikes at a core clad interface. Whether the light can get total internal reflection or the light can escape from the core material, the light can transmit through the core clad interface. That is depends upon the angle of incident at a core clad interface. Suppose this theta I is less than theta C. At the time, this is the angle of incident, this is angle of refraction. The light ray can enter into the cladding medium. And so in the second case, so the angle of incident increases, the angle of refraction also increases. At one particular angle of incident, the angle of refraction becomes 90 degrees. This angle of incident is called the critical angle. In this case, the light ray can travel through the core and cladding interface. Now, the angle of incident increases more. The angle of refraction also increases. In this case, the light ray can get total internal reflection. This is the required condition for a total internal reflection, that is theta I must greater than the critical angle. If you want to find out the critical angle of any optical fiber, you can follow this formula, and according to Snell's law, N1 sin theta I, N1 is the refractive index of core material and sin theta I is the angle of incident equal to N2 sin theta R. If theta I equal to theta C, theta R become 90. Theta R become 90. Now sin theta C equal to N2 by N1. Next, this is the acceptance angle. The light ray can suffer total internal reflection at one certain angle only. Now we are going to discuss what is the acceptance angle light ray can suffer total internal reflection. That is called the acceptance angle. Suppose a light ray can launch into the optical fiber through the air medium. Now it is enter into the core material at a point A and get refracted, and the angle of refraction is R, and it can continuously transmit through the core material and it strikes at the core clad interface. This is the core material refractive index N1. This is the cladding refractive index is N2. Whether the ray can transmit through the core material, can transmit through the core clad interface, can transmit through the cladding material, that is depend upon the angle of incident at a core clad interface. Now apply the Snell's law at A. N naught. Now the light launched into the optical fiber through the air medium. Air refractive index is N naught. Sin I maximum and N1. The core refractive index is N1 sin R. Sin I maximum equal to N1 by N0 sin R. This is equation 1. Now, this light ray can continuously travel through the core material and strikes at the core clad interface. If this angle is less than critical angle, the light ray can enter to the cladding medium. If this angle of incident theta equal to critical angle, the light ray can travel through the core clad interface. Now apply this Snell's law. Suppose this angle of incident at B equal to theta equal to theta c, 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 n1 sin theta c equal to n2 refractive index of cladding sin 90. Now sin theta c equal to n2 by n1. In this triangle ABC, theta c plus r equal to 90. R equal to 90 plus theta c. Now the equation 1 comes to the equation 1. Sin I maximum equal to n1 by n0. Sin, in place of sin r, you can substitute 90 minus theta c. Now sin I maximum equal to n1 by n0 cos theta c. Then sin I maximum equal to n1 by n0 root over, I can write like this, cos theta c, I can write like a root over 1 minus sin square theta c. Okay, sin I maximum equal to n1 by n0 root over 1 minus n2 square by n1 square. But sin theta c equal to n2 by n1. Substitute here. Now, in place of sin theta c, sin square theta c, n2 square by n1 square. Now, you can write like this, sin I maximum equal to n1 by n0 root over n1 square minus n2 square by n1 square. Now, n1 will cancel, and now finally, sin I maximum equal to root over n1 square minus n2 square by n0. Here, sin I maximum equal to sin inverse root over n1 square minus n2 square by n0, where I maximum is the acceptance angle. Here n1 is the refractive index of core medium, n2 is the refractive index of cladding medium, n0 is the refractive index of the launching medium. Finally, the acceptance angle is a maximum angle of incident at a core of an optical fiber, so that the light ray can be guided through the fiber by total internal reflection. This angle is called acceptance angle. It is denoted with the I maximum. The important point is the I maximum occurs when theta equal to theta c at B. Suppose any light below the angle of incident, below the angle of incident, the angle of refraction also very less, and this angle of incident at a core clad interface, this theta must greater than theta c, the light ray can suffer total internal reflection. If beyond the limits, beyond the I, any light launched beyond the I maximum, the angle of incident I maximum exceed the angle of incident exceed the I maximum, the angle of refraction also increases, and the angle at the core clad interface gets total is less than the critical angle, at that light ray can escape from the core material. Now finally I conclude that I maximum is the maximum angle made with the axis of the fiber to get a total internal reflection. I maximum occurs only when theta equal to theta c at a B. Theta equal to theta c at a B. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.